Welcome to the Ellen MacArthur Lectures. My name is Gareth Austin. I'm Professor of Economic History here, and I have the pleasure of introducing the lectures and the lecturer. But before I do that, most of you will know that Tony Wrigley, Sir E.A. Wrigley, died last Friday at the impressive age of 90. So it's worth saying a little bit about him and marking this occasion. Of course, he was a giant of historical demography and also a major contributor to our understanding of the British Industrial Revolution, especially the energy transition from what he called an organic economy to a fossil fuel-based economy. And it's particularly appropriate to mark his passing today, because although everybody thinks of him as a Cambridge historian before and after he went away, he did have an exeat at the LSE and briefly at Oxford. And while at LSE, he popped back here to give the 1987 Ellen MacArthur Lectures, which became one of his best-known books. So could I ask you to stand for a moment to honour with silence the memory of Tony Wrigley. Thank you. The Ellen MacArthur Lectures are, of course, named in honour of Ellen MacArthur, who was, I think, the first woman economic historian at Cambridge and one of the pioneers of the discipline. She was a student and tutor at Girton. She had a doctorate awarded to her on the strength of her published work by Trinity College Dublin at a time when women could not get degrees at Cambridge or Oxford. Perhaps in spite of that, she contributed most of the money that she left to the university to set up what we call the Ellen MacArthur Trust Fund, which supports economic history through prizes, through research grants and studentships, and of course through these lectures, which began in 1968. The very first Ellen MacArthur lecturer was Alexander Gerschenkron, no less, Europe in the Russian Mirror. They normally happen about every 3 years, and Bob was supposed to be giving them in 2020, and then something happened. So here they are today. Bob, I'd always thought until a few years ago, was Canadian, probably because he spent many years teaching at the University of British Columbia, but actually he's from Salem, Massachusetts, did his PhD at Harvard, went to UBC to teach, from there to Oxford, Professor of Economic History at Oxford, retired in 2013 to NYU Abu Dhabi, where he has the appropriate title, Global Distinguished Professor of Economic History. I think it's fair to say that he made his name studying English agricultural history, leading to Enclosure and the Yeoman, published in 1992. After that, he wrote on a whole lot of things, including the, I think, extremely interesting Farm to Factory, a reinterpretation of the Soviet Industrial Revolution, Princeton 2003, which argued against the then increasingly fashionable idea that Russia would have industrialized pretty much just as fast had there been no Bolshevik revolution. And although he argued that the collectivization of agriculture was disastrous, he argued that previous scholarship had underestimated the success of the 5-year plans. So that's yet another major debate, but he's probably best known in Cambridge, at least among economic historians, for the high wages thesis as the answer to the question, why was the Industrial Revolution British? And underpinning that is the method that people other than Bob know as Allen baskets for calculating real wages. So that's I think, a truly innovative attempt to make global economic history quantitatively feasible by coming up with a commensurable measure of the real wages of the poor by considering or by expressing real wages in terms of how much they deliver for keeping a small family alive at bare bones level. That has been much criticized, but it's also traveled, including into my own area of African economic history, where a lot of people have calculated Allen baskets for various African colonial contexts. The perhaps the most obvious feature of his corpus is its extraordinary variety across space, as we're going to hear, across time. So it's no surprise that when Oxford University Press wanted somebody to write a global economic history, a very short introduction, they asked Bob. That was published in 2011. Since moving to the Middle East, he has been working on the economic history of the Middle East, so I half expected him to be offering us a set of lectures on 19th and 20th century Middle East, but there is something Middle Eastern about it, but it's a little bit earlier. The title of the lectures, when Bob first agreed to give them, when they were supposed to be in 2020, was going to be Wages, Technology and Globalization, Inequality over 4 Centuries, 1620 to 2020. But this will be, I think, for those of us who know a lot of his earlier work, an even greater intellectual adventure with the title From Foraging to the First States in the Middle East, an Economic History. I'm glad that we have in the audience some people who really do know about this period in a way that most of us, Bob accepted, do not. So everybody, please join with me in welcoming Bob Allen to give the Ellen MacArthur lectures.
Thank you very much for that very generous introduction, Gareth. It's a pleasure to be here. It is, I'd say, I mean, I want to repeat, it is a sad occasion that Tony Wrigley's passing. He certainly had a huge impact on my thinking on the Industrial Revolution and English history, agricultural productivity and its measurement, and demography, both from reading his work and from teaching it for many years. The Malthusian model and the relationship of demography and economic activity became a kind of central big theme in my mind. And it's going to play out here, not so much today, but tomorrow. Will be very much inspired by Tony Wrigley. So I hope you'll extend kindly on what we're about to try to do. So as Gareth said, the theme of the 4 lectures is From Foragers to the First States. So this is going to be about that theme. The subtitle in economic history is also important because I want to think about these events in this time period. It's the way I tend to as an economic historian. Now, I don't know if this will in the end prove to be a foolish enterprise or whether it'll actually have something to contribute of importance or utility to the effort. But I do take the subtitle seriously, so that's what we're going to try to do. So I'm going to start off with a few introductory comments. The historical problem and social evolution. If I were Rousseau, I might place the Garden of Eden in the Levant 15,000 to 12,000 years ago, the Natufians as its inhabitants. 12,000 years ago, some of them left the garden and took the first steps towards agriculture. With several more steps, humanity reached the first city and the first state, Uruk, about 5,500 years ago. From then, it was just a few more leaps until today. But more time has elapsed between leaving the garden and the founding of Uruk than has elapsed since then. So I think to understand our history, we need to look at the first half of it. And that's the subject of these lectures. I do want to say a little bit about social evolution. So we'll look at a lot of facts in these lectures, which I organize in terms of a theory of social evolution. This is somewhat unorthodox these days, so there's many objections to this kind of approach. For instance, that there's a rigidly defined sequence of stages. There's no human agency. Everything's driven forward by some ineluctable force. But I want to deal with, I think this sort of agency issue is really critical if you want to think in these terms. And I have an approach to that, which is sort of becomes apparent as we go through the things I want to talk about. I do see society in this period evolving through a series of modes of production, from foraging to planting wild seeds, to cultivating with hoes, to farming with plows, to irrigated agriculture. These modes of production have a technological component, as the name suggests, but also an organizational component. But I don't see this as lockstep development, since people have several options. For instance, when a new technology appears that can be used, one is simply to forget it and carry on as before. So I'll give you examples of that as we go on. I'm not just going to give you examples of the people that take history forward, but the people that don't. And they can adapt it, or there may be more than one organizational form from which you can choose. And so we see a variety of forms. So this is another aspect of agency. But it doesn't matter if people don't adopt new technology in its most efficient manner, because in the long run, its use becomes general and society always progresses anyway. And the reason is that the most effective, the highest productivity use of the new options results in the greatest increase in population. And the new adopters thereby become dominant in society. This is going to be my Tony Wrigley theme that gets developed. It's like models of competitive industries. I am an economist. Firms that do not adopt a new technology are often driven out of business by those that do, and the new technology becomes ascendant. So a second area of agency lay in the creation of new technology. Today's foragers are keen students of the plants and animals they harvest and manage them to increase production. And I assume that their predecessors acted similarly. So this is an important area for human independent action. So I've been reading Bruce Trigger's intellectual biography of Gordon Childe, and I was this afternoon remarked on how 100 years ago, no one would say this. This is the antithesis of what people thought at that time, when everyone was presumed to be opposed to progress and uninnovative. A third arena of a human agency lay in the creation of new institutions and modes of organization. So I'll give you examples of all these things as we go forward. Also, it seems to me that the invention of new technology did not occur in a vacuum. When labor was scarce, there was a good reason to economize on it. And conversely, when it was abundant, there was a good reason to use it lavishly to improve the productivity of land and capital. So this means that technology and society co-evolve. It also links in with my theories of the Industrial Revolution. So I see social evolution as a reworking and combination of both Marx and Malthus. From Marx comes the concept of mode of production, with the emendation that a technology might be operated with a variety of organizational models. So this isn't, I'm going to claim this is not technological determinism, because people have lots of scope in deciding what to do with the new technology. But there's an energy for progress, which comes from a Malthusian furnace, which means that the new technology entails that the population using it expands and displaces populations using other modes of production. So in this scheme, the growth of the population becomes an index of progress. So indeed, Gordon Childe used it as his measure of progress. I do not intend this, however, as a moral principle. It's simply a scientific point that the system evolves so that technology advances to raise productivity and to create a larger population. The demographic transition in the recent past has made this model non-operative in the present day, but I think it's how we got here. So this is a complicated table showing you various periods and time frames covering the time we're going to talk about, mainly using a kind of Levantine periodization. So what we're going to talk about in the next two today, so everything starts with the end of the last ice age. And then the next big phase is going to be the Natufians, and we're going to talk about what they did for us, and they're living in the period 13,000 to 10,000 BCE. All my dates are intended to be calibrated years, historical years before the Common Era. And this is succeeded by the PPNA when gardening of wild seeds is undertaken. And PPNA is pre-pottery Neolithic. Pre-pottery, they hadn't invented pottery then. So this is different from China, as we'll talk about tomorrow, where they invent pottery before they invent agriculture. But in the Middle East, they invent agriculture before they invent pottery. So we have two phases, the PPNA and PPNB, which gets us to 6,000 BCE. And that's as much as we're going to talk about today. The rest is settling Mesopotamia and the origins of the first states. So this is lecture one proper, what the Natufians did for us. Information about the origin of agriculture has exploded. Great advances have been made in the hard science aspects of this worldwide search for origins, and many more examples discovered. There's many excavations have been made for many reasons. The technical advances, flotation and archaeology, where earth from an excavation is put into water and organic material floats to the surface and can be skimmed off and studied. And this has been extremely revealing, as we'll see. You find all sorts of old seeds and bits of shells and so forth, and you can make some inferences about what was happening. Also, archaeobotany is the study of these bits of organic matter. We'll talk about that. There's also a genetic analysis of current, mostly current plant material, wild plants and domesticated plants. And there's the study of skeletons has been carried on at great length, which reveal a lot about health in the past. So some of the questions I want to address are these, and these are come from economic history, but they're also common in archaeology. Like, why did agriculture emerge when it did? How did productivity develop, and what were its implications? I hope I can take the measurement of productivity a bit further than this has been taken heretofore. It's one thing I try to do. Did the population expand, and how was its growth related to agriculture? That's, of course, the Tony Wrigley kind of question. And so I want to have a more specific modeling and analysis of that than I think has been commonly done. And I think that proves to be quite revealing about what was going on. How did the standard of living evolve? I like standard of living questions. When and why did inequality emerge? Why did manufacturing, like pottery, metals, textiles, developed as it did, and how was that related to agrarian change? That's a good economic history question. Why did states form, and why did it take so long for them to appear? I mean, the states did probably invent the emergence of agriculture, but it's many millennia before that happened. So what's going on with that? So we're going to begin with the first question here. Where, when, and how did agriculture emerge? So again, if we went back 100 years, there would be just a few places in the world where people imagined agriculture started. This graphic from a book by Bruce Smith shows 7 places: the Near East, South China, North China, Sub-Saharan Africa, South Central Andes, Central Mexico, Eastern United States. All right, so it's already becoming a kind of global thing. And I think the most recent survey of this that I've read lists over 30 places where there's some domestication event of some sort taking place. So the more people look around, the more examples of this they find. So this tells us, I think, something important, that there's just sort of systematic things going on that lead people to domesticate crops and animals. I'm concentrating here, certainly today, on the Middle East, where the so-called founder crops were domesticated: wheat, both emmer and einkorn, barley, lentils, chickpeas, vetch, and flax. Animals are also domesticated, principally sheep, goats, pigs, and cattle. There's dogs too. Horses, donkeys, camels were domesticated elsewhere and imported into the region. The primary attention is going to be on the crops, since they play a much bigger part in diet than animals do. And partly because of my productivity analysis, which indicates that bottlenecks in the production of crops restrict productivity, limited farm development, and it's an important area where there's technical advances that I want to try to unpack. This is a map of early sites in the Middle East, and you can just see by their locations that they trace out the Fertile Crescent here on the east side of the Mediterranean and Levant, up here through northern Syria and southern Turkey, and then down into the Zagros Mountains. That's the Fertile Crescent. And if you look closely at this, which you can't easily, you see that the oldest sites here are all in this arc. So our starting point, stage 0, so I say we can call it the Garden of Eden or the state of nature. At the end of the last ice age, 13,000 BCE, all people in this region, I think, are mobile foragers. So they're moving around from place to place over the course of the year, harvesting various foods. Harsh conditions. So at the end of the last ice age, the conditions for growing things were not great. It was still cold and dry. Harsh conditions and primitive technology meant that moving from place to place over the seasons was the only way to survive. So everyone moving around precluded private property. You had to be able to go to different places. And I think about this in terms of Arabia. If you think of Bedouin in the desert, or sheep herding herders in the steppe, they have to move around to follow the rainfall, which is unpredictable and erratic and can happen here, there, and everywhere. Because that's when it rains, things grow. You need to put your sheep or your camels there for them to have something to eat. So everybody has to move over a large expanse of territory. So you can't divide land up into 640-acre parcels and say that's your farm, because it may never rain there for 10 years and you'd be dead. So it has to be communal. And that has important implications. If you have the Malthusian demography, then everyone ends up at subsistence and all people are equal. And subsistence means that they're going to be quite poor. There's variability from year to year and things. And so everyone there's a high risk of disaster for everyone. And so this leads to the sharing of food, and I think a sharing ethic among groups of people. Sharing's not enough, though, often. So what you find is raiding and plundering. If all of your animals die, or many of them die, you raid someone else and take their animals. This is just par for the course. So you tend to develop an ethic of within group altruism, but antipathy towards out-group members. Whether that meant that life was solitary, poor, nasty, brutish, and short, or people were noble savages because they're altruistic to their friends, I don't know. You can decide. At any rate, the Natufians make the first breakthrough away from this. It's not that they're particularly creative, I don't think. It's just after 13,000 BCE, the climate improves. It gets warmer and wetter. And this means that the landscape becomes more fruitful and more fecund. And so it's not necessarily to roam as widely. And eventually it gets so good that you don't have to move at all. There'll be places where you can have a permanent settlement and go out on day trips to different sorts of environments over the course of the year and sustain yourself. That's what happens. And so the main source of the kind of diets that we're eating were nuts, wild game, and most portentously for our story, the Natufians harvested wild wheat and barley. So as I say, what they did was driven by climate change, the end of the Ice Age, and an improvement in the environment. At some point, they didn't have to move around, so they settled down. But this means that villages precede agriculture. So again, 100 years ago, people would have thought that agriculture preceded villages. But at least in the Middle East, that's not true. Now, it is true in the Americas. Things are different in the Americas, but that's a story for tomorrow. So here, anyway, villages precede agriculture. And Natufians harvested wild cereals, which is the first step towards agriculture. So these are some pictures of, I call them Natufian landscapes, but of course they're not, because these pictures were taken recently and not 12,000 years ago, when things may have been different. But the idea is to show you hills with trees on them, and valleys, flat places, plains without trees. And so when the picture here on the upper right is Dorothy Garrod, who is the person who discovered the Natufian. She was excavating Wadi al-Natuf in Jordan, hence the name Natufians. And she discovered tools and such like that I'll show you pictures of shortly, that indicated that they were harvesting, dealing with grains. So the idea is that the Natufians could live at the place like this where the red dot is, and they could hunt gazelle, which were roaming around on the valley floor, and they could go up in these hillsides and harvest acorns and pistachios and wild grains growing in clearings in these forests. There's an oak tree. So these are some pictures of wild grains. We have wild barley here on the left, and wild wheat growing on a hillside on Karasadog on the right. Karasadog is going to figure quite a number of times in this lecture. So this is a mountain in southern Turkey, just above the Syrian border. So, and you can see the whole mountainside is covered with wild grain. Of course, that would raise the question of why do you ever want to go into agriculture? You can just go up and harvest the wild stuff. That's something to think about. These are some Natufian tools. We've got a sickle here with flint blades stuck in this wooden handle, mortar and pestle, another sickle, a cairnstone and grinder for grinding your grain down to flour. This is another big part of the story, and it takes a lot of time. And this is interesting and important. So this suggested that these people, to Garrod, that and a lot of other people, that they were eating a lot of grain. That's not quite true. So we're now going to go to that's all very idyllic, but it ends. And so we shift archaeological periods to the pre-pottery Neolithic A, and this lasts a millennium. And the thing is that, again, it's the climate that drives the story forward. Here it's a deterioration in the climate. It becomes drier and colder again. This is called a period called the Younger Dryas. The Dryas is the Dryas octopetala, which is this flower shown here. And it's a subarctic alpine flower. And when things get drier and colder in the Alps, it spreads all around. And so this period is marked by this flower becoming much more prevalent. And what it means in the Near East, in the Levant, for instance, is that the oak and pistachio forests die back. They either go up the mountains if it's in Palestine and there are hills, or they move away from the Euphrates River. And so it becomes impossible to stay in one place and forage on day trips. You've got to do something else. This is Gordon Hillman's maps of attempting to plot out geographically what happened to this land cover in the Near East. And mostly you could spend, as I have, like a half an hour looking at these, trying to figure out what the shading means here and there. So I've helped you by shading in here in the lime green. This is before the Younger Dryas. This is when the Natufians are in their ascendancy. And this is the areas they could inhabit, where they could find habitats to do the kind of foraging I was describing. And once the climate deteriorates, this all becomes brown, which is to say, all those trees are dead. You can't do it anymore. And like, so Abu Herrera here was an important site and on the Euphrates, and it was right in the midst of this kind of zone here before the Younger Dryas, and afterwards it's in a dead zone, right? So something's got to happen. So what do you do when the climate goes like that? So there's a whole bunch of options, and people do different things, right? And they don't all start farming. So some Natufians, probably a lot of them, revert to mobile foraging and just go back to moving around from place to place. But in the southern Levant anyway, some of them relocated to places that were wetter because it's got dry, so the grains don't grow there. So you have to move someplace where it's wet, where it'll grow. So they go to rivers, wadis, or oases, and but these are different environments, right? This is not where wheat or barley were the natural vegetation before. There's bushes and other plants growing there. So this is undesirable because you have to now work hard by getting rid of all the competing vegetation and preparing land so that the things you want to grow will grow. So they have to do this by bringing in wild seed from the other place where it was wild and planting it there. So in along the Euphrates, where there were these Natufian sites as well, people can stay in the same place. They're by a river, but they have to start planting in the same way that by actually cultivating the seed, not by just harvesting wild seed. So these are some pictures of wadi adventures, or wadis, in case you're not familiar with them. So these are wadis, big wadis. So wadis are these kind of gullies that come out of the mountains in the Middle East. If there's a big storm in the mountains, you get flash flooding down the wadi, right? And so this is pictures when I was driving around Oman. Suddenly, the road was underwater. I was driving across this causeway here. So this is over a wadi. And it was built here so that when you get flash flood down the wadi, the road doesn't get washed away. But it wasn't high enough here in this case, right? The water was all up on the roads about 6 inches deep. And so it was exciting driving on a super highway in those conditions. These are this is in another wadi near the Musandam Peninsula. And there was a date palm oasis there on the wadi. So I walked through it and I wanted to see how they did dates. And what they do here, so the important thing about this is, like, it's a gravelly area, but there's no stream on the surface, but there's a stream running under the surface. And if you look down, they have wells here. They dig holes, and this is just like a meter down, and you can see this water there in the well. So it's not a big effort to get water up there to water your plants. So that's the kind of environment that people may have been going to in the PPNA sites like this. So these are some maps of various sites on the Jordan Valley, where there's wadis here from along the base of the mountains. And Jericho is a famous site that had a lot of early agriculture, very important site. So it's located right here next to a wadi fan. So it's this kind of environment that people they'll be taking wild seeds from somewhere else and planting it there. But they have the difficulty of having to do actually a lot of work to get it to grow. So the Natufians are famous for harvesting this wild stuff, but actually their consumption of cereals was pretty minor until they were cultivated in the PPNA. So these are data for each point here is a different excavation, a different archaeological site. And what this shows is if they did flotation with the on these sites. So they've taken a lot of earth and put it in water and let organic material float to the surface, skimmed it off, and then archaeobotanists, including perhaps people in this room, would go through every single item and identify the species it was. And indeed, for cereals, tend to identify whether it's domestic or wild. And when you do that, you get a publication. And so you can compute the percentage of all the bits that come out that are grains. And that's what the fraction is here. And so if you look at the Natufian, the blue points here at the beginning, yeah, they've got some grain, but it's like 5% of the total number of bits. So most of the other bits are like acorn bits. So they're eating a lot of acorns and there's shell fragments that have left over. When you get into like the PPNA, there's a big range, right? So some places it's like 80% of the bits are grain fragments. So that looks like they're pretty dependent on, actually growing cereals and eating them. At the same time, there's people down here like at 0 who obviously aren't doing that. So there's a huge range of variety of behavioral responses to this. And it does amaze me that you get even here like 6,000 BC. You've got a lot of places where virtually all the bits are grain, but there's a whole lot of places even then where they're not, where people are still foraging, right? So why do people turn their backs on progress like this? We'll answer that question shortly. So here's an example. Pinnergossi is an example of a site that looks like it was really good for agriculture, but they didn't do it. So this is in near Çatalhöyük, which is a famous town, famous ancient site. It's a picture of Çatalhöyük, not of Pinnergossi. Çatalhöyük's right there, Pinnergossi's there, and they're in this little square here in southwestern Turkey. So they're very close together, right? And so at the time, this is in the PPNB, so they're growing a lot of seed grains in Çatalhöyük. There's no question about that. But this short distance away, these people, they don't do it. But they're located in a place where it'd be really good. It's all wet, so it's a good site. There's a spring there. There appears to have been a lake. There's a lot of marshland. If you look at the kinds of seeds and plant bits that come out, there's all these water plants, so it was really marshy. There's some low-lying hills with wood and grass growing there. So it looks very promising, and yet they didn't do it. So instead, they foraged for wild almonds and hackberries and things like that. And that's mostly what they ate. So didn't bother with agriculture. Domestic seed in this next period, stage 3, develops from wild seed in the PPNB. Domestication in this case means that there's several things that are prominent features of domestication. One is that there's no spontaneous release of seed. So wild plants, wild wheat or wild barley, the seeds ripen at the end of this little stalk that they're on. When they get ripe, they fall off and they disperse. That's how the plant seeds itself, right? Seeds when it's domesticated, they don't fall off. Right, that's the point. And so when they're domesticated, when you take them back to the barn, then you have to thresh them because you have to break them off manually because they don't come off, naturally. But the advantage to you is when you try to harvest stuff that's growing wild, you lose a lot of it when you're taking it to the barn. And so that's the difference anyway. Also, domestic seeds tend to be bigger and there are more seeds per stalk, so you get a bigger yield that way. And they have less armor and penetration aids to get in the soil on their own. And I think they generally seed tends to germinate. Domestic seed, when you plant it in wet soil, it'll germinate. Whereas wild seed, it's very dependent on day length, the length of the day, all kinds of other factors like that, season of the year, so that it's not very controllable when it's so wild. It's got its own built-in calendar. You get rid of that, then you can plant it whenever you think it's best for you. So most of these things, as well as some other things, can be identified archaeologically by archaeobotanists, although I mean, it's almost like magic to me. I look at pictures of these seeds that are said to have the hard rachis because they're domestic versus the soft rachis that are wild, and I can't see anything, but that's not my field, but I'm impressed that people can. There's a genetic basis to domestication. So the phenotype, which is the actual manifestation, the seed that you actually see, for instance, the plant you actually see, has to be linked in a simple way to the genotype, which is the genetic code of the seed. And the simplest is if there's a one-to-one correspondence, so that a particular single gene, whether it's on or off, means that the plant is domestic or not, right? And then without a correspondence like that, it's pretty impossible to domesticate or to become domesticated. So the idea is that somehow, in most cases, like somebody can select on the basis of some observable characteristic, and then that'll actually be selecting for the genes that govern the characteristic, and then you can get domestication easily. And so how did domestication happen? There's several models. There's conscious domestication, which I was just describing. So which I think of as an improving forager, my Victorian view of life. So the forager can observe the phenotype and plant seed of the best version. So, generally, you might want, if you're interested in cultivating lentils, you may want big lentils rather than teeny tiny lentils. So it might occur to you to take seed from that's big and plant it in the hopes of getting plants that give you more big seed. And if there's a simple correspondence between the phenotype, which is what you're looking at, and the genotype, that works. And indeed, that seems to work with lentils. And it works with all sorts of vegetables and fruits. It works, I think, with maize, but it doesn't work with grains like wheat, barley, or rice. The key thing here is the whether or not this has got like the so-called hard rachis, whether the domestic seed is hard rachis, so it's firmly attached to the stalk. Soft rachis means it comes off naturally in the environment. And almost all wild stuff that's growing there has got a soft rachis because that's how it reproduces naturally in the wild. And there's about a 1 in a million probability that a mutant hard rachis seed will be out there in your field. That's hard to observe, and nobody thinks it was done that way. So there's some very interesting research by Hillman and Davis where they try to model this, and they claim that if you harvest in certain ways so that you lose some of the soft rachis stuff, you can effectively, the process will have the effect of concentrating hard rachis genes. And then they do computer simulations, which suggest to them that this could happen in as little as 20 to 200 years, which seems extraordinary, and indeed is extraordinary because that's not what happened. It took more like 3,000 years, 2,000 or 3,000 years to go from, from all wild seed to basically domestic seed. And it's a little, I think it's fair to say this is still not well understood what's going on with this. But that's what happened. That's the time frame anyway, over which it happened. And it had to do with how humans, must have had to do with how humans cultivated these wild seed. But precisely what they were doing that had this effect is still not entirely clear. But another thing that happens at the same time, though, that is possibly clearer is that seeds get bigger on these grains, and there's more of them. So you would get more yield from with domestic, but a stalk of domestic wheat would have more wheat on it than a wild one. So this is another, and you could imagine people selecting on that basis for bigger seeds. So where, when, and how did this all happen? The where question was the first to be addressed. Nikolai Vavilov was the director of the Leninol Union Academy of Agricultural Sciences in Leningrad in the 1920s and early 30s. He sent expeditions around the world to collect seed and made the world's biggest seed collection in Leningrad. And he had seed from domestic seed from all over the place, and seed from wild stands in the same, wherever they could find it as well. And so based on this kind of evidence, he could find areas of potential domestication where there was the wild stuff was growing, at least in the 1920s. That was suggestive of where it might have happened. And this work has been extended and refined. And these are some maps from a recent paper showing you the areas where einkorn wheat, emmer wheat, and barley wild stuff is growing even today in free stands. And so the emmer stuff is that traces out the Fertile Crescent very nicely. The einkorn is a broader area, but certainly includes the Fertile Crescent, as indeed does the barley. Now, there's letters here that I've added to this graph. So K is Karasadog. So this is the mountain that you saw a picture of in southern Turkey with a wild einkorn wheat growing on it. So one of the other areas of scientific advance on this is to collect many, for instance, seed samples from many domestic stands and many wild stands across the Middle East. So you have einkorn. And then you do genetic matches between all of the domestic stuff and all of the wild stuff to see which wild stands are closest to the domestic stands. And the most spectacular discovery has to be with einkorn wheat, where it's all, the domestic stuff all comes from Karasadog. That's where it all started. So that gets a big K right there. The other stuff is never quite so clear cut and dramatic, but it looks like there's emmer wheat domesticated in Levant there, and also near Karasadog. Chickpeas are there with a C. Lentils are there with an L. Barley's got two centers of domestication, one in the Zagros Mountains and one in the Levant. So those look like places where this domestication happened. And it turns out that the earliest sites with domestic grain show predominance of the locally domesticated seed. So these are early sites pre-8000 with domestic seed. And so this one in the Zagros Mountains, the seed is barley, right? So that was where a domestication event was supposed to have happened, and that's what they're growing early on there. These two, the orange and the blue, are emmer and einkorn wheat, and they're right up here by Karasadog, where there was, both of those are supposed to have been domesticated, but they don't have barley there, right? And they don't have wheat down here in the Zagros. Here's more wheat here in the northern Levant, and here's barley down here near this domestication. I'm not quite, yeah. There is another, these sites, there are sites on Cyprus which are quite early with domestic stuff on them, and they're unusual because they've got everything. And there's wild barley that's there, but the wheat all had to come from the mainland. So that's a story we'll get to. So as the PPNB unfolds, you find that most places are growing all three grains, right? So we've got these little target-shaped icons I created here, which show you barley, emmer wheat, and einkorn wheat, and almost everything's got that stuff. There's still some just mostly barley places over here, and around Karasadog they just don't do barley up there. They've got that wheat, but otherwise everybody's pretty much doing everything. And so how's that? What's going on there? And so what it means is that there has to be a big interregional trade in grain seed, one way or another, right? Because like all the einkorn wheat is coming from Karasadog, and yet they're growing it all across the Middle East. So how'd they get there? And probably it goes on the obsidian trade routes. So there is interregional trade happening in obsidian. So this is the Stone Age. So if you're going to have stone tools, the best stone tools are obsidian. And obsidian comes from either Cappadocia in Western Anatolia, or up here near Lake Van in Eastern Anatolia. And so there's a route that kind of goes down here, over here, down the Euphrates, across over here, down the Rift Valley, down the Jordan, all the way to the Red Sea. So you find, obsidian going down there and Red Sea shells going up there. And then there's trade across here into the Zagros. There's another, it's not shown very well on this, but there's another route into the Zagros taking obsidian there. So, obviously we don't know how this is organized. Is this commercial or what's going on, but there must be some kind of trade activity like that. So another question is, who were the domesticators? So everybody growing wild wheat, wild grain was a potential domesticator, even if they didn't know it. So that's the burden of the kind of Hillman Davies view of things. They might just inadvertently pull it off. With many of the vegetables, it's probably the improving foragers who like they select on big seeds and plant them, and they end up with plants that produce more and more big seed than they had before. So that's a good thing, right? So our archaeology gives us some vignettes of what was actually happening on the ground. So this is sort of weird, right? You think about writing history, you usually like to explain, here's examples of things, and that people did this and that. And you can see somebody actually made a decision. We can actually almost see that happening. Not quite, but we can get there by looking at some site reports of what's going on. Anyhow, so here at Çatalhöyük, you saw a picture of Çatalhöyük earlier. There's a paper that where Amy Bogart and a lot of co-authors identify the houses of innovators. So one of the things about Çatalhöyük's got lots of houses. They're all packed together, and they are growing seeds, right? With agriculture there, and people store. Well, they find seed in particular houses. Right? You excavate it, and there's seed, and you can locate the seed in a house. And so what they were able to do was carbon date every single seed grain individually to get the timing of that. And then they could identify them as new varieties of sometimes the same crop and see who was doing the new stuff. Right? And so they could identify the houses of innovators and the houses of followers. So this all seemed, I found this quite fascinating. And it shows that, crop choice in the first instance was apparently done at the household level, right? Because houses differ in whether they've got new stuff or old stuff. And some farmers were risk-taker innovators, and some were apparently risk-averse followers. So it just sounds like today, right? And the land tenure system allowed this variety in cropping choices, right? Because you had some people bringing in a new kind and some an old kind, but whatever the land tenure system was, it didn't preclude that. So it sounds all kind of modern. And if people are experimenting like this, what you expect to see are a lot of kind of mistakes, blind alleys, false choices, and you see those false starts. So this is from another excavation, and this Sheikh Abad in the Zagros Mountains. And so this graphic shows you it's divided into time levels. So the bottom level, it's older, and the top, top is more recent. And there's even yet another layer, which isn't shown here, which is I'll tell you about. And so the columns show you frequencies of different kinds of plants and seeds and stuff. And we don't need to know too much about the details here of that. And the thing is, though, so you look at the bottom too, the oldest trenches, there's a big variety of what they're doing. There's some of this stuff that's our medium-sized grasses. These are small grain grasses, all these other things. They've got a whole range of stuff. So that's what the seed assemblages show. But then you get up here to 7600 BCE, and suddenly it's almost all the same thing. There are these small seeded grasses. There's 4 species, and that's what they've got. And the other stuff's all dropped off. So it looks like what these people decided to do was to focus all their efforts on these particular crops, these particular plants, because they could eat them. I mean, this is food, right? And they seem to have decided that this was the best thing to do. So it's this kind of concentration of effort on particular crops that leads ultimately to domestication, right? But the trouble is, these didn't go anywhere, right? I mean, 2 of them are perennials. So, I mean, actually, all the crops we cultivate are annuals, right? So perennials have all sorts of issues about actually this for farming. And they just didn't do it. And so the more recent layer, which isn't shown in the graphic, is they drop all those medium-sized seeds. They give them all up and they just plant domestic seed, right? So here they were beavering away on this line of advance they thought was going to do them good, and it just didn't pan out, right? And so they went for the good stuff when it got available. So there's a lot of that, and that's kind of what I expect if you have improving foragers, each kind of trying to pick a way to go. And it also shows agency in action, right? But it also shows why social evolution goes the way it does, because in the end, they gave it up because agriculture was better with the standard domesticus. So that's what becomes the dominant technology, and that's where people go. Here's another example of a place, another village in the Zagros, which shows the transport system in action doing this. So this has got, Chogagolin has got good stratigraphy over this whole period when all this domestication is happening. And the key thing is it's like this. In 78, 89 BCE, very precise, the main crop that they're growing is wild barley. So this is in the area where there's wild barley, so this kind of makes sense, right? They're growing wild barley. And there's evidence that over time, if you look at earlier periods, the barley seeds are getting bigger. So it's like they've been selecting for big seeds, which may lead to domestication. But the next strata, which is only 8 years later, 78, 81, they stopped barley, and it's been replaced with domesticated emmer wheat. So that's not local. That comes from Turkey, right? So somehow this domestic seed has come down the Obsidian Trail from Karasadog, and they've seen it. Somebody tried it, and it's clearly better than the wild barley. So they just give up on the wild barley and they go for domestic wheat. So again, you know, you can sort of see just how this kind of plays out as people experiment around and go for the best food source. Cyprus, which I mentioned before, is another example. There's no indigenous human population on Cyprus. There were settlers in the PPNA who introduced wild wheat, and they brought everything over with them. So they wanted to hunt, and the animals they liked to hunt in the Levant weren't indigenous to Cyprus, so they brought them over and released them so they'd have wild animals to hunt. So they kind of reproduced everything. And then they just stay there practicing the same kind of PPNA culture. And then there's further settlement in the PPNB, which apparently brings in domestic seed. But the first guys over there, they don't go for that. They like the old ways, so they just stay with it. Plants are only part of the story. Animals were also being domesticated. I'm going to have to speed up here because I have to. So the animals, sheep, pigs, goats, and cattle are wild in the mountains in southern Turkey and the Zagros Mountains, and they get all domesticated by and taken to other parts of the Levant and Mesopotamia and Turkey. I kind of like the Valiev's experiments on breeding foxes because they show that change can be pretty fast and many traits are linked. So what happens with these things like cattle is it looks like the first stage of domestication is that people start managing the herds and they start killing off older males. So they start harvesting older males, but otherwise, and that the herds as they are carry sort of develop naturally, and then when they're taken to other places, you begin to get changes in the morphology of the animals that are associated with domestication, like they become tamer and they lose their horns and things. And so Valiev's experiments on breeding foxes, while somewhat controversial, are interesting. So he decided to select, he bred foxes, which are wild, and he controlled the breeding, and he bred them for friendliness. So he'd find only the most friendly foxes and have them breed together, and then amongst their offspring, the most friendly ones, breed them together. And after 60 generations, virtually all foxes are friendly when you do that. But other things are amazing too. You get all these juvenile characteristics like whining, barking, and submissiveness. They become general. They start licking their keepers. They have floppy ears, mottled coloring, wagging tails. They just become like little dogs, like domestic dogs. So, narrower snout, smaller teeth. So all these traits are apparently linked genetically. So just selecting on friendliness gets you all these other things. So, presumably, if you're going to be raising cattle, you'd like the bulls to be friendly. So if you start trying to, if this influences your breeding, you can bring along a lot of other characteristics like this with it. So why did people take up farming? Why did they do all this? The classic answer is that it made them better off, but it didn't, as we'll see. There's going to be a two-part answer to this question now. Why did they do it anyway? One answer is sort of the immediate answer is it's the best option under bad circumstances. In the next lecture, we're going to have a more comprehensive analysis of this when we look at it in this Malthusian framework, but we're not doing that today. So the point of departure here is what's called human behavioral ecology. And part of that's called optimal foraging theory, which is microeconomics applied to foraging. And it's very simple in practice, which is what we're going to do. So what you do is you make a list of all the possible food sources of your foragers or your farmers, your foragers say, and you for each one of them you compute the return rate, which is the amount of calories you get per hour of work. And so you get a list of all possible options and these return rates. And if you do this with almost anywhere, what you find is the things with the highest return rates are big mammals. So if you can kill a buffalo, that's really good, or a mammoth, right? And if you have to go and plant seeds, that's really bad. That's way down the list. And so the hypothesis is that what people do is they basically take the highest, they go for the highest return rate they can. And once they've done that, once they've killed off all the big mammals, then they go to small mammals. And eventually they work down to things like acorns and stuff. And eventually they may have to do agriculture when things get really bad. So I want to apply this to this issue, these issues here. So I want to compute the return rates for foraging and for early agriculture and later agriculture, indeed, in the Middle East. So foraging. So we have data on einkorn wheat on Karassadog, for instance, because an American agronomist named Jack Harlan went there with a group of graduate students in the 1960s, and he had his graduate students harvesting wild wheat on Karassadog and measuring how long it took them to get it. He wanted to know if it was possible for people to have lived on harvesting these wild cereals. And so he wrote interesting, this is a picture of, I presume, one of his graduate students. They made replica Stone Age tools to do this with, right? And so this would be a good summer job. If I was a graduate student, I'd really like to go off and do something like that. Anyhow, so there's data on that. And so you can compute how many calories you get per hour of work. And it's about 1,100. And you can also do this with acorns. So acorns is the nut. And so acorns, that's important like in the Middle East as a food source. It's important in China as an alternative in the Yangtze Valley when they're domesticating rice. And it's also in California and the Sacramento Valley. It's a big deal. So that latter is useful because there's a lot of American anthropologists that study Native Americans. And so they've done all these kind of measurements and figured out what return rates for acorn harvesting and food preparation are. And it works out to be about the same with einkorn wheat as with acorns in the Sacramento Valley. It's about 1,100 calories per hour. And if you're interested, that's my calculations. The only thing, so there's collecting, and the important thing about both of these activities is processing is actually much more bigger source of, take more time than harvesting. So pounding, winnowing, and leaching acorns, or milling and dehusking and milling especially wheat, there's a lot of hours. And so in these calculations, you have to decide what you're going to end it with. So I take this like to be producing flour and not cooking the flour into food, right? But everything's got to go to flour or the equivalent, something like that. So it's worth remembering this, that milling is really, and so it's women that do the milling and the grinding. And you see it in their bodies. We'll look at pictures next time, because they have all these repetitive stress injuries in their skeletons from doing this, because it takes many hours a day and it wrecks them. But the upshot of it is you get about 1,100 calories an hour from both activities. So that's good, because people, if they're doing both of them, should be getting the same return for both activities if they're optimizing their labor allocation. What about cultivating wild wheat or barley? So there's really three environments to consider. Flood recession agriculture. That's where you plant by the bank of a river whose height changes a lot with the seasons. So, when the flow is low, the river is very low, then there's a big flow, like in the winter, say, it goes up really high, then it goes down again. So if you have that kind of pattern, when it's up really high, the land you want to plant on is underwater. So that kills everything, all the grasses and stuff. So when it goes down, you don't have to do much soil preparation. You don't have to plow it. You don't have to till it much. You can just put seeds in it. So this is what people do on the Niger and the Senegal rivers and stuff like that. That's what they're doing. Wadi or garden agriculture, you can plant in a wadi if there's some sort of water source there, and that's good. So these are important when it's dry in the PPNA. Then there's rain-fed agriculture, which is that's just relying on rain. So I needed yields. So this is a little more complicated. This is all these calculations that are done on a per hectare basis, because most of the stuff is per hectare, but it all ends up the same way. Labor requirements, like you have to seed, you have to harvest, you have to weed, all these various things that have to be done. They come from well, 3 for irrigated farms and then modern rain-fed farms, but they all have to be discounted because of harvesting losses in the PPNA and so forth. I'm not going to go through all the details, but that's what's going on. And then labor requirements come from experimental studies. There's a lot of experimental archaeology that I've taken labor requirements from, and then from other sources. And so we get more complicated tables like this. The top part here is all these various labor things, hoeing, harrowing, planting, weeding, harvesting, threshing, you're dehusking, and so forth. And on a hectare, so we've got, these are the foraging things you saw before. The last 3 columns are flood recession agriculture, wadi fan agriculture, or rain-fed agriculture. We get these various hours for a hectare's worth of flour. Then the yields, those are the kind of normal, the modern yields, as it were, the 3 yields. Then there's these discount factors and seed requirements. And we get down to effective yields, which are much less. I could explain all this more. You convert all that to calories, you compute the return rates, and the upshot is that farming is really bad. Right? Foraging at 1,100 calories per hour. The best farming thing is flood recession agriculture at 772. So that's not 1,100. Wadis are down at 501, and rain-fed stuff is 287. So it's just beyond the pale. So with such low return rates in farming, can people survive? The answer is barely. So I'm going to do this particular question in lecture 3, but the calculations there show that the largest farm that a family could cultivate, taking account of seasonality issues like tilling and harvest times and the length of them, the largest farm they could the family could cultivate would give them enough grain to provide each family member on average with 1,800 calories per person per year. So 1,800 calories is really low. I mean, that's like a population average, but this is like the bottom third of the Indian calorie distribution. So you can, a society can survive on that, but this is bad. This is the bottom. So they could barely survive. So should the Natufians have taken up farming? And the answer is not if they could help it. This shows you the return rates, calories per hour of work for the various systems. Foraging's way better. This is the hours of work that you'd have to do under these systems. Foraging's definitely better. You know, the other stuff just takes a lot more time. So if you could find a good foraging site that was not overcrowded, foraging was always preferable to farming. So then why did anyone farm? And the answer is they had no better option. What with bad climate at the younger Dryas destroying all these good foraging sites, you know, if they weren't going to be mobile foragers, then they were going to have to do this PPNA agriculture and plant wild seeds. But that was a real bummer. So they're left with a curse, you know, by the sweat of thy brow shall thou eat thy bread. Thank you.
Thank you very much, Bob.
Thank you.
So we have time for some questions. We're going to finish sharply at 7. If you are watching online, you can submit your questions through the Q&A function, please. And if there's time, I'll select some of those questions to ask. But meanwhile, I'll open the floor. While people are gathering their questions, let me just ask one. That is, I presume somebody has asked or has investigated whether you had similar climate changes in other parts of the world in which domestication subsequently happened, to see whether they didn't choose the right option and just died, or they migrated to where they could still forage.
I don't think that this climate, I don't think there's a parallel explanation to the younger Dryas elsewhere. In fact, its trajectories seem quite different, but this is going to be lectures 2 and 3.
Okay, well, I see these 2 questions from coming. I should just say, because of the privacy legislation, if you choose to give a question, then you are implicitly consenting to your question being orally recorded.
Thank you very much.
Yeah.
Thank you very much for your very interesting lecture. I was fascinated by your conclusion that farming actually took longer than foraging. So therefore, should we rename the Neolithic agricultural revolution the Neolithic industrious revolution?
There is an industrious revolution. I hadn't thought about it in this context, but lecture 3 has the industrious revolution. And it's a lot like the one you know about, because we get the introduction of manufactured goods, which I think does play an important role in increasing labor force, as it were, labor force participation. So stay tuned.
Thank you. Thank you very much for the course.
Yeah, obviously terrific, loved it, learned a lot. Thanks very much, Bob. So in the spirit of the Monty Python title of your lecture, my question is, what about thank you for all the fish? Which of course is another classic. In other words, to be more a little bit more analytic, we haven't heard anything really about water and the sea as yet. Maybe that's to do with the kind of dynamics that's available, but the areas we're talking about here, the Euphrates water. I mean, I know you talked a lot about water in one sense. What I'm talking about is the areas of sea that are on your maps, like the Mediterranean, the Black Sea, and so on. And we talked about obsidian, and you showed us an overlap route for trade. So I was just wondering, this is an area of the world where there is sea around, as well as big rivers. And are we, is it just the case that we don't know what was going on in the sea with fishing and with trading and with using boat-based technology? See, I can ask this out of pure ignorance.
So it's very interesting. All right. And so a lot of the area where this action takes place is not on the sea.
Yeah.
All right. And that's so in particular, like southern Mesopotamia is not there. So the Fertile Crescent, right, it goes up the sort of pounce on the western Levant across Turkey and then down the Zagros Mountains. So it doesn't happen in Mesopotamia, right? And this is where like civilization is supposed to be starting, you know, in the future, right? So one of the reasons that it's not happening in southern Mesopotamia is because that's basically mostly marsh and underwater, because at least in the 4th and 5th millennium, the Persian Gulf is much higher and it's flooded way inland. The runoff, apparently, I mean, the rainfall levels in Turkey are higher, so there's more runoff of the Tigris and Euphrates. And so the whole area is basically wet. And so you couldn't, it's completely different, right? And then, so part of the story that happens, this is lecture 4, is it dries out. And so we get a big, you know, the sea level is playing a big role in what's happening there anyway. The other part is, which I don't know that anyone knows about, is like in the Mediterranean and the Cyprus story.
Yeah.
So it's clear there had to be a lot of movement, you know, shipping going from the mainland to Cyprus to bring all these various animals over and waves of colonists and so forth. And this is happening at an early date where I don't think anybody ever imagined people could do that. They had the boats, like where the boats come from. Nobody had the earliest model boats, for instance, from Mesopotamia or the Gulf area are like 6th millennium. So like thousands of years later than this stuff's happening. And I don't think there's any model boats from any place in the Cyprus or the Levant that show seagoing. Maybe I'm wrong here, that show people how people would have done it. So that's a big mystery. So I commend that to anyone who's looking for a good project.
Thanks so much. Thanks so much for that. It was very interesting, and I'm very excited to see economic historians sort of engaging with this material and thinking about it and applying the models. One of the more substantive claims that you made was that a lot of these crops were moving around due to interregional trade. And so I was just wondering if you wanted to speak a little bit more about how regular the sort of interaction and how regular the economic interactions between communities would be that you think would sort of sustain those kinds of sort of crop transfers. Presumably, if the crop can move fairly quickly, it doesn't have to be a regular exchange.
Well, that wouldn't, yeah, you just, if it's the seed that's going, once the seed's there, if it's planted and it works, then you'd be self-seeding in the future, right? I don't know. I don't know anything. I don't know that anybody knows anything much about the volumes that are going on this. I mean, it's not clear like who's doing it even. Like, do we imagine that there's somebody who gets obsidian and Chattanooga takes it all the way around, or does it go some stuff sold to the next village, to the next village next? Is it something like that? I don't think there's any way of pinning anything like that down, but it's obviously important. The only other thing I know about this, though, is that it's the transport mode is on your back at this stage, right? There's no draft animals. So that all comes later, right? And there's no pack donkeys. I think this is too early even for pack goats. I was surprised. There's websites that tell you how to raise pack goats, and with data on how much they can carry and how many people herd them. And I don't know if anybody was doing that, but that was so people have to be carrying it. So I don't know. that's not all that efficient, right? I show you data later which shows the costs of human portage versus donkeys versus boats, and it's dramatic as transport costs fall as the technology changes.
Okay, I know 3 questions. You're first, and then following up.
Thanks very much. And like Adam, I'm really excited about you're bringing your expertise to a prehistoric period. That's really great. One of the things that happens when you do that is you get these different time scales, and you mentioned at least 2 changes that were measured in thousands of years. So you mentioned the fixation of domestication genes in 3,000 years, and the decline of foraging, which is even longer. In terms of the first of those, I personally very much doubt that any, given the human lifespan, I doubt that anybody living at the time actually noticed that anything was happening. And so, with those millennial changes, how do we as scholars attach that to human agency?
Well, it's a very good question. You know, I agree. Like in the grain stuff is very hard to see, but no, as far as I know, nobody has a very clear idea of really what's going on. So I guess so, but the closest that I qualify that, I don't know if this counts as knowing what's going on, but a statement I've read quite a number of times is it's one way or another, it's the process of cultivation of the wild seed that leads to domestication, even if we don't know what it is. So cultivating the wild seed, is intention, right? Beyond that, I don't know. I'd like to know the answer.
Thank you. I think this touches on several of the questions that have been asked already, so apologies if the answer is still, we don't really know, but I was just, and especially the first question about the Industrial Revolution, I was just thinking throughout that a lot of the emphasis is on the cultivators making choices about efficiency and that kind of thing, but to what extent is it actually driven by, taste? Like, does emmer wheat taste better than barley? Or, I guess, and some of this comes back to, trade. We don't know how any of this is actually happening. We don't know how people are describing these tastes, but is there a way of measuring these things as being driven by, preferring?
I'm doing experiments on this. I'm eating them. No, I'm serious. I was reading, this is actually, the roots came from other work I did before this on making up international poverty lines. And I had these linear programming models of diets that I was using. And one of the results is that the least cost way of getting the diet with a bunch of nutrients that you specify in it, generally in many parts of the world involves eating sorghum or millet. And if I run these models on India, I frequently get that as the least cost diet. So I've talked to people though who study India, and they say, but people in India don't like it, right? They don't want to do that, and I wondered why. And so I bought sorghum flour and I bought sorghum grains, and I discovered maybe why. So it tastes really good, right? That's not the problem. The problem is that if you want to make bread, with the flour, so we're talking like making chapatis, right? You make your chapati and you start rolling it out and it falls apart, and you fry it and it just crumbles and it's all crappy bread. And and then a moment's thought revealed the reason, because it's marketed as a gluten-free food, right? And without gluten, it doesn't make good bread. So if you want to have bread, sorghum's no good. The other thing is if you can boil it like rice, and it's very tasty, but there's 2 problems. One is that you have to boil it for at least an hour to get it soft enough. So if fuel is a problem for you, that's no good. And the other thing is, even if after an hour when you eat it, it's still pretty crunchy. So if you've got bad teeth, it's going to be a big problem. So, I mean, I think it's things like that. I bought einkorn flour because I read that nobody makes their einkorn. You feed it pigs somewhere in Slovenia. I mean, it's like that. So I made bread with einkorn, and I think it tastes pretty good. I mean, I don't really know why. I liked it actually better than, wheat bread. So I don't know why it's gone out of fashion. It's probably more expensive, right?
I think there's just one more.
Oh, sorry. I'm talking too
Maybe
much.
just one question in the room. There were a couple of questions online.
I'm also one of the archaeologists who really enjoyed an economic story and getting into this area. I think you did also brought across really well in the time of dramatically changing climate, how people did have agents and they did take choices, and some pathways led in ways they couldn't have seen. The study of this whole topic is, in a sense, is determined by the fact that we know what happened. We all talk hindsight. It's very easy to get to they would have seen this, it would have been more efficient, as Martin said, in people's lifetimes, but they wouldn't have seen. One of the more interesting things in recent years, looking at these studies, one of Martin's students, Durham Fuller, and then Yasuki, they looked at a lot of the context of the PPNA sites, the cereals, and the tools for handling them are both in highly ritualized contexts. The way it gets us into, if you like, there's the common sense dietary arguments, and you're quite right, as you said, it also led to pathways. We know that health conditions got worse as a result of this. You have to face 12,000 years. Not many people doing things 5,000 years, one way or another, they are drawn into like a health basis. But to say that in this curious time, this PPNA, its first 1,000 years or so, one time a year, they're all in these highly ritualized contexts. And what do you think of that argument? I don't think this will follow myself, but how a lot of these things that became food staples may have been important, but not for food staple reasons at the beginning. And people argue that for maize and for sorghum and for wheat and barley and rice and so on. But they may have had kind of magical brewing. They may have had all sorts of functions where they were attractive to foragers in different ways. And before they became the dietary staples that we know they were to become, they did.
Right. So it's, I think about this one. I don't have a topic. Yeah.
That question actually puts in a very specific way, one that Jay Higman raised online, which is, while as an interloper I'm chary to question the rationality of Homo economicus, what are the role of less calculable factors like culture or spiritual beliefs? So you've got time to come back on that. And that, there's also the question, how do macro or micronutrient profiles fit into your calculations? Some calories and vitamins or minerals may be more biologically valuable than others.
On the second question, that's true. And so I feel like I'm I'm on very thin ice here. So because I've written a lot of papers about how just looking at calories is a bad thing, and famine relief organizations that simply look at whether people have enough calories and give them maize flour to make up for the gap. This is bad, and this leads to all sorts of health problems and early death, and yet here I am doing it. I think I guess what I would say is that if they're eating, if the diet is mostly like barley and wheat, and if they actually have, I didn't make it an explicit part of the model, but I presumed that they were getting 20% of their calories from hunted game or raised domesticated animals. If they have that, they're actually getting enough calories, certainly enough protein. If they have some sort of meat like this, they're They may be on the fat margin. That's actually the macronutrient that's often least in supply. But if they're getting game or meat to any degree, they're probably not too constrained. And they probably do have deficiencies of some of the other vitamins. But a lot of people in the world, so I don't know, what do we make of that? So a lot of people in the world live like that, poor people in poor countries. They have a lot of deficiencies, right? Most of the Indian population is anemic. They don't eat, many people don't eat meat, right? And they don't have other sources of iron, and so they're anemic. But they function, you know, I don't know. So what do we make of that?
That's a very good thought to leave it on. Vishal, who has an interesting question which online, which I think you may be addressing tomorrow. So if it doesn't come up in the lecture tomorrow, please ask the question again. Meanwhile, thank you very much, Bob, for this first lecture. I can't wait for the second.